We're going to use logarithmic functions to solve real-world problems. Earthquakes, whether you knew it or not, is solved using a logarithmic function. They call it the Richter scale, but here's what the equation looks like. R is the intensity of the earthquake. Then here's the rest of the equation, where A is the amplitude, and T is the period of the seismic wave in seconds. B is the factor that counts for the weakening of seismic waves. Describe and analyze the function given this. So here's what we're going to do. We're going to plug this into the calculator, but what we're going to do is put an x here. So I'm going to graph log of x over 2.1 plus 5.4. So my base is 10. Something you could figure out from this is it should be shifted up 5.4 units. And this here, normally when you divide, it would be something smaller. Because it's on the inside, this will actually be a horizontal stretch by factor 2.1. Let's see it. So we go over to calculator, and I'm going to add a graph here. I'm going to say log, and the base was blank. You can put 10 there if you wanted to, or you can leave it blank. It should still work. I'm just going to double check and make sure it works. We have that, and then we have plus 5.4 on the outside. And so this here would be our graph. Now the calculator doesn't show the asymptotes going down or the graph going down forever, but it is. So there we go. We would have this, and if I wanted more information, I could add in the asymptotes, things like that, to the graph. You know, remember how normally we have a y-intercept of, or excuse me, an x-intercept of 1, 0. Now we should have one where that would hit is not 1, 0, but that would be 1 and 5.4 there because we shifted it up. So that should be there as well. We have a horizontal stretch, so it would be going that way. Now it said describe and analyze the end behavior. Well, as we go left, it doesn't go left forever, but it does go to the right side of 0. So I could do this one. And they called this function on f of x, they called it r. So I'll do r. As we go to 0, or left of 0, excuse me, the right side of 0, our graph goes down to negative infinity. And now as I do the limit, as x approaches the right of the Richter scale, it goes to positive infinity. So on the right side of 0, it goes down to negative infinity. On the going to the right, it goes up to positive infinity. So now, using the same problem, it says find the intensity of the earthquake with an amplitude of 250. Amplitude's the A period of 2.1 seconds, that's the time, and B of 5.4. So basically what we're doing is we want to know what R equals when we have log of 250 over 2.1 plus 5.4. Two ways you can do this. So since we already have this graph, you could go to your table by pressing Control-T and skip down to 250. Now to get there quicker, you can press Menu, Table Settings, and edit Table Settings, and just say, let's start at 250 and see what the value is. When the x is 250, the Richter scale says that for your answer. And so you could put it that way, or another thing you could do is just simply solve it. I want to open up a new, press Control-Dot, get a new window, go calculator. You could just type it in. We want to know what the log, it did not give us a base, of 250 divided by 2.1 plus 5.4. And this should also give us the exact same answer. So both of these would be ways of getting the answers here. Is you could go table to 250, or you could do this as well. So whichever way you prefer, both will give you the right answer. All right, now let's look at part C. Let's see, it says the city is not concerned with the earthquakes, the intensity of less than 3.5. An earthquake occurs with an amplitude of 250 microns, period of 3.3 seconds, and a B of 1.2. What is the intensity? So this time it's saying we're not concerned unless this is over 3.5. But they changed some values. A is now 125. So we'd have log of 125 divided by 3.3 seconds. No, 0.33 seconds, I'm sorry. And we have a B of 1.2. Now let's see what this equals when I type this in the calculator. I'm just going to go here and type it in here. So we'll have log, and this time it said it was 125, I believe, over 0.33 plus, was it 1.2? I forget. Let's check this real quick. Yeah. We press enter. We get 3.77. And so, yes, we would say, since this equals 3.77, they should be concerned. Because it is over 3.35 or 3.5, their threshold. All right, and now part D. It says, earthquakes with an intensity of 6.1 or greater can cause considerable damage to those living within 100 kilometers of the earthquake center. Determine the amplitude. All right, amplitude. This time we're looking for A, whose intensity is 6.1. So the intensity is the R. So this time we're going to say 6.1 equals log. We don't know the amplitude, but we do know a period is 3.5 seconds. So 3.5 is the time. And the B is 3.7. And we have to solve this. Logarithms only have one answer, so you could insolve this, or you could graph it with this as an x and see where these two intersect. I'm going to go do insolve right here. So you press menu 3.1, menu, algebra, numerical solve, and I'll type this in. 6.1 would equal the logarithm, and we know this is base 10, but I'm going to skip it, of, control divide, we are looking for an amplitude here over, I forget the number, 3.5, and then we have a plus 7 right here, plus 3.7, and we want to solve all this for A. So that's how you do a numerical solve in the calculator. And so this is saying the amplitude has to be 879.16 to receive that type of intensity. So you can see that's pretty crazy here, how high this number is. So the amplitude equals 879.16, and this is in microns. And that would be your solution here. So you've just seen how to solve this problem a bunch of different ways. Let's see if you can solve this one.